Okay, so I'm going to go through what is your classification of reactions flowchart and the Google Slides example problems. Okay, so this right here, the very first one, would be a synthesis reaction because you have two smaller things combining to create something that is all combined together and bigger. Okay. Um, so let's say that we're looking at the second one right here. So this was number one, this is number two, and this is number three. Okay. So we're looking at the second one. How do I go about using this flowchart? All right. So the first question asks, does the equation have any single element species? What does that mean? We'll look at all of these. Is there any element symbol that's just by itself, meaning one capital letter? And the answer to that is yes. It's O2. That's our single element species. So the answer would be yes. Okay, so redox is the first classification you can give it. It's a redox reaction. Okay, now it's going to ask other questions because we got to keep going down. You go until you get to the end, just like a board game. Does the equation have O2 as a reactant and CO2 and H2O as products? You got to remember that the arrow splits the problem, and your reactants are over here. And your products are over here. Okay. So O2 is not a reactant here. It's a product. So the answer to that would be no. Does the equation have two single element species? The answer is no, because the only single element species that I had mentioned is O2. All right. How many reactants does the equation have? Well, if we look, it only has one reactant, H2O. That's its own species. So the answer would be 1, and that means that it is decomposition. You have something bigger that's breaking down into two smaller things, or even more. Okay, so now let's go ahead and look at number 3. It's saying it's a single displacement and a redox. We always start when we're using this chart at the very top where it says start, and you go until it says end, or it gives you a final destination classification. So does it have any single element species? It sure does. It has two of them. It has Al and H2. All right, so the answer would be yes. So redox is your first classification. Does it have O2 as a reactant? Do we see O2 anywhere here? No, we don't. Okay, so that would be a no. All right. Does the equation have two single element species? If we go back, it has Al and H2. That would mean it has two single element species. So we follow the yes arrow. Next question is, are both single element species on the same side of the arrow? So are Al and H2 on the same side of the problem or the arrow? The answer is no. So that would mean that it is single displacement. And if you look, Al switched places with H. That's really all they did. Okay. All right. So now we're going to go on to 4, 5, and and 6. All right. So we got this big old nasty reaction here, combustion. The first thing we always just start with is, does the equation have any single element species? If we look, it does. It would be oxygen. All right. So redox is our first classification that we would give this. The next question is, does the equation have O2 as a reactant and CO2 and H2O as products? Remember, the arrow splits the problem. Reactants are over here, and products are over here. O2 is a reactant, and if we look over at the product side, we have CO2 plus H2O. That would make this a yes, and it would be combustion. And so you are done. You've classified the equation. All right, next one, number 5. It says it's acid base and double displacement. Again, when you're looking at your chart, you always start at the top. Does the equation have any single element species? Do we see any single capital letters all by themselves in this equation? The answer is no. So, how many species does this equation have? Well, it has one here, one here, one here, and one here. That sounds like 4 to me, which gives it its first classification of double displacement. The next one that, because you got to go down the arrow, is does the equation have an acid and a base for reactants and water as a product? So remember that acids start with H, so we have an acid here, and bases end in OH, so we have our base. So we got our acid, we got our base, and if we look at the product side, we have our water. All right, and so if we have those things, it would be acid base. Okay, so we have acid base. So the answer to that question would be yes. And then we have to ask, is there a solid on the product side only? If we look at the states of matter, I see L, which is for liquid, and I see AQ, which is aqueous. No solids, meaning the answer is no, and we stop at the red stop sign. Finally, the last problem we have, it's classified as double displacement and precipitation. We got PbNO32 plus KCl yields PbCl2 solid plus KNO3 aqueous. So we always start at the top. Does the equation have any single element species? Are there any capital letters just by themselves? The answer is no. We have all compounds here. So the answer to the first question would be no. How many species does the equation have? Looks to me like it has 1, 2, 3, 4. So double displacement is our first classification. So now we keep going down because there's an arrow coming off of it. Does the equation have an acid and a base for reactants and water as a product? I don't see anything that starts with an H, and I don't see anything that ends with an OH. So the answer to that would be no. Okay. The next question, is there a solid on the product side only? So if we're looking at the product side, do I see an S? I sure do. And that would mean that it is precipitation. And what precipitation means is that you created a solid. Okay. Hopefully this helps a little bit for all of you, working on stuff that's brand new to you. Shoot me a message if you have any questions.